Welcome again, everyone, to today's presentation. I'd like to also welcome Rick France running our Q&A in the background. We're going to be talking about AutoCAD and the dynamic blocks. This is going to be a simplified presentation of those. There's a lot of things you can do with dynamic blocks, so I figured the best introductory workflow to those would be keeping things as simple as we can. So let's go ahead and get started into this. Real quick introduction on Hagerman & Company. If you're not aware, we have offices from coast to coast. We've been in the software sales and implementation industry for over 30 years. And the technical staff like Rick and myself combined, we've got over 175 years of field experience out there in the trenches with you folks. So the agenda for today, when you're working on a drawing, and you've got a lot of symbols to work with, a lot of geometry to work with. Of course, step one is simplify that geometry as best you can so it's one selection. So you're going to convert it into a block, select that block object, copy it, move it around, rotate it, what have you. And dynamic blocks allow you to add more functionality than just that one static symbol. So we're going to look at basic blocks versus dynamic blocks, what those differences are. We're going to look at the process on how to create some of the dynamic blocks, and we're going to look at the different type of dynamic block functions. And real quick before we do that, I'm going to launch a polling question. So just want to get everybody's input on this. What industry do you primarily work in? Architectural, mechanical, electrical, civil, or some other industry, which may also be a mixed industry. All of these industries can utilize blocks, more so in some industries than in others. Architects and electrical, you guys have a lot of symbols to work with. Civil has a lot of symbols. Mechanical does too, but not near the level of quantity or complex nature of symbols as some of the other industries. Most things in mechanical are kept pretty simple. All right, looks like we've got some good responses so far. About 80% have voted. So I'll go ahead and close the poll. And if I do this right, I can broadcast the results. So it looks like overwhelmingly about where I figured it would be. 32% of you work in some kind of mixed mode situation. Architectural, mechanical, mechanical and electrical, things like that, civil and architectural. So I'm not really surprised by that at all. That's pretty well where I figured it would be. So I've got one other polling question to look at, and that is a real simple one. Do you currently use any block objects? Wow, that was fast. Immediately jumped up to 100%. We've only got about 2% voting. So blocks can primarily save time on the drawing process. It can reduce your lead times if you have a lot of geometry that's unified into a block symbol. And depending on how you organize your templates, your brand new drawing template could have every block you could ever possibly need in that one drawing template. Obviously, you would want to go back and clean this up and not leave every block known to man in your template or in your resulting production drawing, so you can purge out what you don't need, but it is a good workflow practice. So sharing those results, overwhelmingly 93% of you do use blocks. 7% of you don't, and that's good. That's an introduction for those who don't to see what this can bring to you. Let's go ahead and hide that and move back into the presentation. Maybe. Ashley, how do you close the poll and move back? Got it. Nope, I don't have it. Thought I had it. There we go. Okay. So looking at dynamic blocks, what's the difference between a dynamic block and a standard block object? Well, standard block object being a set of pieces of geometry that you've unified into one symbol. Lines, arcs, circles, polylines, what have you. Text, dimensions can even be part of that, you name it. Whereas a dynamic block allows you some flexibility. A standard block is static. A dynamic block can have multiple behaviors for changing size, changing location, changing different dimensional parameters, patterns of objects, even lookups and visibility options. So the one master symbol gives you really infinite possible combinations. You also have a reduced symbol library size. So like I was talking about with your drawing template having all of your blocks in there, any of them that you could need at a moment's notice, having everything in a dynamic block will reduce that library size, make it a lot easier to find the stuff you're looking for. You can custom map information to each sub symbol in the dynamic block. And of course, it's going to increase your productivity. It's going to make you a lot faster to change sizes of this geometry. With dynamic blocks, there are some different icons that come into play. So the standard block incorporates a square, a blue square. It's a grip, just like an object grip on other pieces of geometry. This typically represents an insertion point for that static block. Dynamic blocks are the same way. They're going to have that standard grip square that represents the insertion point, but it can also represent other designated points. You also have other things such as a list pull down, either to pull up various choices, options, different sizes, different pieces of text that may be displayed, different numbers, call outs, what have you. You have an alignment grip that allows you to align the object to different pieces of geometry. So taking a door and aligning it horizontally or at an angle to a particular wall edge. You have directional flip options that will flip the direction of the object. You have a scale, a stretch, and a ray option, and you have a rotate option. All of these grips can be used all at the same time, or this one versus that one, or a couple of these here, a couple of these there. So there's no real rule that says you're limited to 1, 2, or 3 grips. You can use as many as you need to accomplish the task at hand. When you're creating a dynamic block, you're going to be doing this in the block editing environment. So step one, you've got to create that block. You got to take that set of geometry, convert it into a block, take that into the block editor, and then start making changes. The block authoring environment has a series of tool palettes. In vanilla AutoCAD and all of the verticals, there are at least 6 tabs on the block authoring tool palette. In AutoCAD LT, however, there's only 4. The ones that LT are missing are one of the limitations of AutoCAD LT. That's working with constraints. AutoCAD LT can still work with dynamic blocks. It can still create them and work with them. For that matter, it can still work with objects, blocks, or otherwise that were created using constraints, but LT cannot make edits to those constraints. Various tool palette tabs for the process to define parameters versus creating actions based on those parameters. You also have parameter action sets. You've got the constraints to work with, and then dimensional controls as well. So let's get into this and look at the demonstration. Stepping back and looking where blocks can come into play. Standard, typical house plan. Got a cutaway of the floor plan. We got some layout for the lot, the surrounding terrain. You've got some trees, bushes, hedges here, even down to inside the wall structure, you've got or can have outlets, lights, switches, cabinetry, things of that nature. There's a lot of potential here to use blocks and or dynamic blocks. And depending on what you're going to need out of that symbol is going to determine which one you should be working with. So for example, looking at the representation of a light, there's not really a lot of lights that come into play on an interior floor plan. You could have 2, maybe 3. That could be a dynamic block option, but most builders try to stick with one consistent light fixture. So that one symbol will represent pretty much every light in this floor plan. Similarly, outlets could be under the same control. You could have one type of outlet block symbol that is a simple block object. It has one grip. Same thing could be said for a light switch. Simple block object with one grip. However, we're in a situation here where the outlets could be 3 different types. You could have your standard 110, you could have your GFI, you could have your high voltage. So that is one of the situations where a block or a dynamic block might be most beneficial to you. Also looking at things like doors and windows. If I do a grip edit on that door, you see there are multiple grips associated with that. Those grips allow me to change direction, change size, change the wall thickness, things of that nature. So I could flip and say, well, either it opens inside or opens outside just with one click. Or I could say hinge left, hinge right kind of situation. You also have the option of changing the amount of open for the door. So if it's open 30 degrees versus 45, 60, 90, or even if it's closed. Additionally, how wide is the door? This grip over here allows me to resize it to say from 3 feet to a 3'4" door. Size it down 2'8", 2'6", get the idea. Not only that, but you also have the option of the wall thickness, a 6-inch wall versus a 5-inch versus a 4 3/4 versus a 4-inch. This is all information built into the symbol, part of that block authoring environment. The trees are the same way. With the trees, I can change from the plan view of a deciduous to an elevation view if I'm making a different type of drawing view. That's all the same block. So we're going to walk through how to make various types of dynamic blocks. To begin with, let's talk about the basics of constraints. This is one piece of technology that AutoCAD LT does not have in it. And constraints allow you to define rules and laws between objects that govern their behavior relative to other objects. So when we're looking at something like an object snap, if I draw a new line segment and I do an O snap to the end of that line, come up and make my line segment, that object snap only works for the time of creation. It references to that endpoint of that horizontal line, and that's it. Once you're done, nothing keeps those 2 line segments connected. So if I move one line segment or rotate one line segment, that connection is now severed. So nothing maintains that connection. But constraints can do that with the proper assignment. In AutoCAD, constraints come in the form of the parametric tab. That is a ribbon tab that you may not have turned on. You can right click on any tab, go to the Show Tabs flyout, and make sure parametric is checked. With the parametric tab, it's divided into geometric constraints and dimensional controls, as well as parameters and being able to delete those constraints. What the constraints allow you to do, you've got 12 different types here, such as coincident, collinear, parallel, perpendicular. They assign those behaviors between the objects, and those behaviors will remain until you go back and delete that constraint, if that's something you even want to do. Most times you're going to leave it. So looking at something like a coincident constraint, I can put a coincident constraint between the endpoint of the horizontal line and the endpoint of the vertical line. What that does is it moves them into contact with each other. Now, if I grip edit one of these and I go to move it, you'll notice they stay connected. Those 2 line segments keep their connection points. So this functions very similarly to what a polyline would do, but it's not a polyline. You're still looking at two individual line segments. I could apply those constraints to the rest of the situation here, constraining these endpoints. And now I can take and grip at it, and that box, all connection points stay connected. Again, similar to what you would see on a rectangle shape, which is a polyline. So if I go a little bit more down that path, looking at something that should be an I-beam, we're going to get it there, but right now it's not there yet. There's a lot of constraints that I could apply to this that would govern its behavior and kind of force it into that I-beam shape. Now, to come through here and do individual constraints on endpoints, that's going to be very tedious and time consuming. So luckily, there's an option to auto constrain. When you auto constrain, you can select your objects. You can even go into the auto constraint settings and choose which constraints take precedence and which ones you want it to look for and which ones you don't want it to look for. So right now I'm going to have it look for pretty much everything. Say OK, and it will apply those constraints as it sees fits the condition. So you've got some coincident constraints on the endpoints. You've got some collinear where the top edge and the bottom edge line up with each other. You've got parallel for edges that are, or objects that are parallel with each other. You've also got horizontal, you've got vertical. So it applied all of these constraint conditions to control that geometry. Well, here's what that does. If I hide all of these and I grip at one of these lines and grab that grip, you see it now moves the entire set of geometry. We're not at a block yet, but we're going to get there. This gets you really, really close. More importantly, it assigns that behavior to where you can control this thing and have it change its size and position based on other pieces of geometry. So for example, collinear on the two edges here will bring them in alignment with each other. And if one edge moves, the other edge is going to move with it. So now that my flanges will always stay the same size. I could do the same thing for the centers. I could do the same thing for the thickness. So I can make both the top and the bottom equal thickness. As you apply more of these constraints, you're controlling that behavior of those pieces of geometry. You could also apply dimensional parameters to control the sizes of that geometry. So right now it comes up at 5.4 units. I can say, well, let's make this 4 units, and it'll resize that geometry and bring it down to fit that condition. Dynamic blocks, blocks in period, and dynamic blocks can use these constraints, but again, this is a limitation that is not in LT. So let's look at the process of making that block object and then turning it into a dynamic block. So I'm going to start out with a cover plate. Just going ahead and define my block definition. I'm going to create this block. My insertion point is going to be based on the center point here. And my select objects, I'm just going to window around to grab everything. Other options in here, you can choose the units of the block. You can have it convert this set of geometry to that block or retain their original individual object definitions, or even delete it. So in the situation of a template, maybe you're done with this and you want to delete it and get it off the screen, but it'll still be embedded in the drawing. You can also have it be annotative to adjust for annotation scaling on paper space mode or in the layout mode. Scaling it uniformly, and you can also prevent exploding, sort of. So I'm going to go ahead and say OK. It converts that geometry into a block. So when I grip at it, I get one grip. It selects all of that geometry. So there's blocks 101. That's the basic form of a block. Now we're going to change that. So I'm going to edit this block. A couple of ways you can do that. Either you can double click on it, or you can right click on it and go to block editor. Either way is going to get you there. In the block editing environment, we have access to those tool palettes we were talking about earlier. There's your parameters, there's your actions, parameter sets, there's constraints, again, not in AutoCAD LT. You also have these same commands across the top under the dimensional panel, the manage panel, actions parameters panel. I'm going to use the tool palette and I'm going to define a limiter, linear parameter control. So for that, I'm just going to zoom in. I'm going to go from the endpoint to the endpoint on the top of that outlet. You'll notice it calls out distance 1. This is not really a dimension per se. It's not giving you the value. It is a parameter that will reference the dimension between those two objects. It's not necessarily controlling them. It's more or less just a call out reference that you can use for your actions. That's what we're going to do next. We're going to create a stretch action for that distance. Various types of actions you can do: move, scale, stretch, flip, array, lookups. So I'm going to use the stretch. And for the stretch process, I'm going to select that parameter that I want to work with. That's going to be that distance 1. It's going to ask you to specify a location point for the grip of that parameter. I'm just going to put it out here at the endpoint. That'll work just fine for me. Then it asks you to specify a frame, and the frame basically is just a visual representation of what area of this piece of geometry or this set of geometry, what area does that command apply to. It's not necessarily defining the objects, it's just denoting the area of control. So I'm just going to draw a frame around this area here. Then the final prompt allows you to select the objects. So these are the objects that I'm actually going to stretch or modify with that stretch action. So I'm going to do another crossing window through the end of that outlet cover. Say enter, and you have an icon up here for the stretch action. Now, if I go ahead and close my block, save my changes, and test this out, you'll notice I now have 2 grips. I have the center insert point grip, and I also have one up here at the top. When I grab that one at the top, you'll notice I'm able to stretch that outlet cover and make it wider. Now, this is a good one for a blank situation, but I need more of these outlet cutouts to be patterned through here. So I've got some changes I need to make. So I'm going to come back in here, back to the block editor. And this time I'm going to use another action. It's going to be an array action. When I choose array, I'm going to select that same parameter, distance 1. Then I'm going to select the objects that I want to create the pattern of. So I'm going to pattern the internal cutouts. Then it asks for the distance between the columns. Well, that's going to be 1.8. That's how far my cutouts are going to pattern relative to each other. And notice what happens when I press enter. So right now it's asking me for the distance between the columns. When I press enter, it's done. You'll notice it did not ask about rows or the distance between the rows. The reason for that is it's based off of the orientation of that distance. So this is a perfectly horizontal distance control. It's a column distance. So that's the only one it's asking for. Now I need to do a little bit more tweaking to this before I finally go out and test this. I'm going to look at the properties on that distance. I'm going to scroll down in my property list, and there's a value set section of the properties. I can change that to either be an incremental value or even a list of values. So if I go to the list of values, you get your distance value list below it, and you can click the icon to bring up the dialog and plug in as many additional values as you want. So I'll say 4.6, 6.4, and 8.2. So I've got 4 different distances this thing can pattern out to or stretch out to. Go ahead and close my block editor, save my changes. Now when I do a grip edit, I can resize it, and you'll notice it snaps out to that next increment. So it started at 2.8, that's the size it was. It grows another 1.8 units, and it automatically patterns the cutouts. You'll notice I cannot go beyond that maximum limit that I put in there. It does not allow me to go beyond that. If I need more, I need to go back in there and change it. But what this allows you to do is with that one block symbol, if I copy this in here 4 times, the same symbol allows you 4 different configurations using the same set of geometry. So there's 4 different configurations of the outlet cover, all from one symbol. Now there's a lot of symbols that come with AutoCAD. So if I look on the view ribbon and I bring up the main tool palettes, there are a series of tabs down through here that have block symbols in them. You've got a mechanical tab, you've got annotations, you've got architectural, electrical, civil, structural, and these are different block symbols that you can pull from that comes with the software. So if I look at architectural, for example, you've got some doors, imperial units, windows, you've got studs, you've got toiletries, trees, vehicles. You also have metric versions of those. Looking at the mechanical side of things, a shoulder screw, you got an anchor rod or an anchor bolt, you've got roller bearings, but you'll notice some difference between the icons. Notice some of them have a lightning bolt and others don't. The ones without a lightning bolt is a standard block. They're your traditional block object, single grip, one use. That'd be an equipment label that you place, has your geometry, attribute tabs, whatever. But a block with a lightning bolt is your dynamic block. So if I go with a shoulder screw, for example, place it out on my drawing, when I grip at it, I get those multiple grips with that dynamic block to allow me to change the length of the bolt, change to different configurations, different sizes. So that's the difference in the tool palettes versus the icons without the lightning bolts and the icons with the lightning bolts. So let's keep plugging away and look at a few other dynamic block behaviors. Here we've got a standard doorway. We've got your doorway opening. We've also got your door casing, a little bit fancier than the traditional one that comes with AutoCAD. These are blocks. So 3 different block objects here, just standard run-of-the-mill blocks. Actually 2 blocks and a polyline, I should say. So 1 block here on each end, and a polyline in the middle. We're going to convert all that into a block. So I'm going to define a new block, calling it door. Make my insertion point out here at the midpoint. And my objects are going to be the 2 blocks and the polyline. Go ahead and open that in the block editor to save some time. Now we're going to start applying a similar situation to this. We're going to use the stretch command, but we're also going to do a couple of other dynamic block behaviors. First and foremost, we're going to have to define that linear control. That first linear control is going to be the width of the door opening. So I'm going to put that distance out there, and then I'm going to come back and create a stretch action. Same thing we did a minute ago with the outlet cover. So I'm going to pick the distance, then pick the endpoint for the stretch icon for the stretch grip, then specifying my frame and specifying my objects that I want to stretch. At this point, if I come out here and test this out, I can stretch it to any size I want. That's not a good usage case for a door. I want some kind of control on this. So I'm going to come back in here, and on that distance, we're going to do the same thing we did a minute ago. Set it to a list of values and plug in various values. So 3 foot, 3'6", and 4 foot door. And you know what? We'll go with a 2 foot door. Okay, so now when I come out of my block environment and I go to stretch it, I can shrink it down to 24 inches or all the way up to a 48-inch door. All right, so that's getting the behavior more in control with what we want to do. Now we're going to look at applying a rotational control to open the door at various angles. So looking up here on parameters, there is a rotation parameter. With the rotation parameter, the base point is going to be back here at the hinge location or the hinge point of the door. And I'm just going to come out to about the midpoint to locate that rotational section. The default angle, we're just going to go with 0. We'll come back and change that here in a second. So now when I edit on that parameter, come down here and look at the same value set, instead of doing a list, which I could do, I could also just do an increment. So I can give it a minimum angle, I can give it an incremental, and a max. So the max is going to be 90, and the increment is going to be every 15 degrees. Then the action for that is going to be a rotation action. So that's going to be the parameter that I just defined, and the object I'm going to rotate is the polyline of the door. That's it. When I close my block editor and save my changes, now when I grip edit, grab that rotational grip, I can rotate up in 15-degree angles. Notice I cannot go beyond that 90-degree max angle that I specified. One more dynamic grip for this guy. We're going to put in an alignment parameter, which is very handy, especially in an architectural situation with doors and windows. So the base point of the alignment is going to be out here at the inside of the casing where it contacts the sheetrock. Then you're going to define the orientation of the alignment. That's all you got to do. When I close the block editor, save my changes. All right, let's draw some different walls out here. So we'll go with a vertical line, go with an angled, and a horizontal. So now when I grab this block, first and foremost, we've got our stretch to change to the different sizes. We've got a rotation for the door opening. Turn off my ortho. And we also have this little house looking grip. That's your alignment grip. So when I zoom out and I grab the alignment grip, watch what happens when I go to the angled edge. I'm not clicking, I'm simply hovering over it, and it's turning or rotating the door to match that alignment. Do the same thing if I come down here to the vertical edge. Huge step saver with just that one grip. Okay, lastly, we're going to look at probably what is my favorite dynamic grip, because it was the one that impressed me the most when I first saw these things. That is the visibility swap out. We've got a series of trees here. We're going to make all of these into a block, keeping the base point at 0. Go ahead and just take them into the block editor. Now, what I'm going to do is I'm going to create a visibility parameter and then define which objects are visible based on which visibility state I choose. So I'm going to lay down the visibility glyph. Actually, I'll probably move it down below, get it out of the way for now. And once I have the visibility parameter in there, I now have access to the visibility panel in the block editing environment. You can create visibility states, and you can create as many states as you want. This one I'm going to rename and call it Tree 1 Plan View. Make another one and call it Tree 1 Elevation. Go ahead and make a few more. Say Tree 2 Plan and Tree 2 Elevation. And finally, Tree 3 Plan and Tree 3 Elevation. So those are going to be my, oops, wrong one. Try that again. 3 So I'm going to have 6 different combinations of this block. Go ahead and say OK. You'll have a pull down up here to work with each one of the different configurations. So tree 1, plan view. Okay, how do you associate objects to that visibility state? Well, there are 3 icons across the top. You've got a visibility mode, which basically turns everything on or turns everything off regardless of your state. Or you can say, well, I want to select the objects to make visible under this state, or select objects to make invisible under this state. That's the one I'm going to use. So with tree 1 plan, that's going to be this guy right here. I'm going to select all of the other objects to make them invisible. And they're gone. If I go to tree 1 elevation, everything comes back on. Now I need to do the same thing. I need to make invisible these guys over here, as well as this bottom one, because this is the plan view of tree 1. So I'll go ahead and make those invisible. And then I'll just take and move this object set here and put it on 0, 0. So it and its corresponding plan view have the same insertion point. So now if I cycle between those, there's tree 1 plan and tree 1 elevation. Keep doing the same thing with the rest. Tree 2 plan, similar workflow. Want to make all of those invisible. Done. Relocate this guy to 0, 0. Switch to tree 2 elevation. Move that guy to 0, 0. Tree 3 plan. And then lastly, tree 3 elevation. Oop, missed some things. Go down here and clean that up. There we go. Tree 3 elevation. Make all of those invisible. And move that one into place. Okay, now if I cycle through these, tree 1 plan, elevation, 2 plan, elevation, 3 plan, elevation. This is probably one of the simplest dynamic blocks to make, but in my mind, it's also the most powerful one, because you get that ability to literally swap out all of the objects associated with that block. So when I close my block editor, save my changes, test this out. Now I've got this pull down here at the bottom. I can change to the different tree configurations using that pull down method. Very powerful stuff, especially with something like this versus a plan versus an elevation versus a cutaway situation. Okay, so now let's look at what next steps you might want to take. There are some training options that we have available. We do offer an AutoCAD advanced course. That is a 2-day standard course. It is part of our standard catalog offering. We offer it routinely. There's a link to it there on the screen if you want to go check it out. The advanced course does cover, it does have a dedicated chapter for dynamic blocks. We also have an AutoCAD Dynamic Blocks dedicated course. Now this is a half-day course versus the AutoCAD Advanced being a 2-day. There's a lot of other topics being covered during the AutoCAD Advanced, but during the Dynamic Blocks course, it is focused solely on dynamic blocks. Again, it is a half-day course. There's also the third option for custom courses. And a custom course, sky's the limit on something like this. We tailor the course to fit your specific needs. So there's some Q&A up front to find out, what are you doing? What do you hope to accomplish? Looking at the points in between, what kind of geometry are you working with, and what topics do you want to cover? So the time of a custom course will depend heavily on the topics and the objectives that we're going for. So those are the offerings we wanted to present, and I believe one of the questions on the survey has to do with being contacted about training. So there's those, and we also offer other things such as an AutoCAD Basics course, which also covers creation of blocks. Doesn't really get much into dynamic blocks, but at least get your foundation for basic block creation. With that, we're going to look at the questions. And Rick, how are we looking? Any questions that need to be addressed?
No, I'm getting a few right now that I haven't addressed yet, so we can go ahead and do that. Let's see. The first one is, do you have a dynamic block library available for purchase for a specific industry?
We do not. We being Hagerman, do not that I'm aware of. There are some sites out there that will allow you to download some dynamic block libraries. A couple of them you can grab for free. I've grabbed a few here and there, but there are some that also charge for it. The first place I would probably check is the Autodesk App Store. I've noticed there are a few block-related libraries showing up on there every once in a while, even though it's not technically an app. It's piece in the software that you're going to be using. So I would check the App Store first to see what's available. You might find something for free. But aside from that, my best advice is a Google search and careful what you click on kind of thing. But we at Hagerman, as far as I know, do not offer a block library for purchase.
I don't know if you have time right now or anything available for this, but anything that you can show of how chain actions work within dynamic blocks, or is that something we'll just be covering in the dynamic block class?
That would have to be covered in the dynamic blocks class because we're running low on time.
And it is fairly complicated to show in a demo in a short amount of time. So I apologize that we won't be able to do that today. What is the cost for the classes just mentioned?
Very good question. I don't deal with the money, so you can contact your Hagerman sales rep. They're going to have those costs for you. The less I know about the money, the better. But I believe, again, part of that survey that you can complete, one of the questions in there is whether or not you wish to be contacted. I would definitely answer yes to that one. And the Hagerman sales rep for your territory would be in contact with you soon.
Okay, and do you offer courses on Lisp and AutoLisp? I'll go ahead and answer that one. We don't have any standard ones, but we have done that in the past. I actually have one coming up. I'm the one who teaches that normally. I have one coming up here in just a few weeks, but it's for a particular client who ordered it custom. So most of the time when it's Lisp, it's going to be custom class. Although I would contact the sales rep if enough people are asking for it, they would definitely put it on the calendar.
Yeah, I mean, there's
standards. It's always worth asking.
Yep, it's a pretty simple thing when we get enough people from various companies, various industries. A lot of times we can kind of make a generic blanket class to cover the topic, and with Lisp and programming like that, I'm sure there's some things we could get stitched together to kind of do an introductory course, if you will. Comes up a lot of times in the Inventor world and the Revit world as well.
Okay. Different visibilities to the person asking that question may want to look into. Oh, I'm not sure what that was. That wasn't really a question. Do you have a dynamic? Let's see. Some of these I haven't had a chance to answer, so they're not leaving my screen. Do you use scripts to create or customize blocks?
You can. That's not what Dynamic Blocks is doing, but you can incorporate some scripts for very unique niche fit situations. It is not something that's done routinely, but it is a capability that's there.
Okay. Let's see. Can you tie a text attribute to a distance parameter to display the dimension?
Text attribute to a distance parameter to display the dimension.
think that would be something you could do through a field, possibly, maybe.
Field or a lookup table. That's the only two things I can think of right now. With a lookup table, you would have to have that dimension in there, which you should be able to reference that distance parameter and pull that. That's something we'd have to test to see if that workflow is valid or if it's something else.
Right. Can you make text dynamic in blocks?
Dynamic in what sense? You could have text swap out. You could have text be visible versus not visible. That's another one we have to dig deeper.
If you insert a dynamic block into an existing drawing with the block of the same name, will the existing blocks move? I think what he's asking there is, as long as there's not attributes, you would have to do an at sync on it if there's attributes. But other than that, if something in the block is moved, it's going to go to its default state for anything in an existing drawing.
Right.
Man, bunch of them. Unfortunately, they are not sorting very well. I appreciate your time. Are there courses that cover dynamic blocks within LT specifically? In other words, some of the LT stuff's not available, but any courses on that, I'll let you answer that if you have an answer.
Yeah, I have actually taught the AutoCAD New User, the AutoCAD Advance, both of those with vertical AutoCAD flavors as well as LT. So while there are a couple of things that LT cannot do, those courses tend to be geared to include LT. With the fact that LT cannot do constraints, typically the courseware does not cover that information. I'm not sure on the topic list for our custom half-day dynamic blocks if constraints are covered or not. Because constraints are simply, it's another piece of technology available to vanilla AutoCAD that dynamic blocks just so happens to also benefit the use of. It's not specific or solely proprietary to the block environment. As you saw, I was outside of the block environment using constraints.
Can a lookup table be used with an attribute so that the information can be exported?
Exported, I'm not sure of. Can it be used with an attribute? Yes.
Okay, and can dynamic blocks be used with Civil 3D pipe network elements, specifically the visibility state function?
Civil 3D pipe network elements. That one is a little beyond my scope because I don't know Civil that well. Any idea, Rick?
I don't know Civil that well, but I do know that with things like in AutoCAD Electrical and Plant 3D, it's not going to work with anything 3D at all. And it's going to have like in Plant 3D, we can use it with annotations, for instance, but not the actual symbols. Electrical, you can't use it at all for symbols that are going to be defined in electrical. So my guess is there might be some capability for it to be used in Civil for annotation and stuff, but it's going to be very limited. But I'm only guessing. That would take a little more research, and probably someone like Scott Hawker would know that, who's our main 3D guy. Can you add part number changes when a dynamic block changes?
Part number changes when like the field of information, can it change when the dynamic block changes? Yes. Where was one I just saw a second ago? Does annotative text work in dynamic blocks? Well, the block itself can be annotative. So if you're having the block adjust based on an annotative scaling, then the text within it would adjust accordingly. If you're asking if it can be adjusted separate and the block be static, ooh, that's a good one I'd have to test.
Did I ask the one about can you use scripts to create a customized block?
I believe you did.
Okay, and then someone's asking about dynamic blocks for bill of materials. I've used them for data extractions. I've also used them with AutoLisp to create bill of materials from it. So it's possible, but as far as if you mean the actual bill of material itself, probably not going to be very useful for that unless you're just making it stretch the number of columns and rows.
I'm going to go back to the question, if you insert a dynamic block into an existing drawing with a block of the same name, will the existing blocks move? One catch, if you have a drawing that has a block, a standard block named door, and then you try to drag and drop a dynamic block from another drawing also named door into the first one, it's going to want to overwrite the door that's in there. It's going to ask you if you want to do that, of course, but it's going to want to overwrite it, which means any of your doors that were already in drawing one, which were standard blocks, would be replaced with the door from drawing two that is a dynamic block, which means now all of your doors you had in place become dynamic blocks. Will they change position? Yeah, if the insert point is different between the two objects, yes. How do dynamic blocks affect attributes? Can they? I think we need more information on that one. There's a couple of these we'll probably have to get back with you to answer because it's going to require some testing.
They're going to affect attributes the same way as a normal block with attribute. You're going to have to use @sync to make it update if you've made a change to the block definition, and attributes could be shown in different visibility states. That's about it, though.
Oh, here's a good one, and it bit me a few times years ago. Sometimes when I make a block with visibility options, the triangle used to change them disappears when the block is moved. Why does this happen, and what can I do to prevent it? Be careful when you're selecting your make visible, make invisible. There's been many a times I've actually accidentally picked that triangle and made it invisible. So it might be a situation like that. Also combined with some of your other actions that could be changing what happens to that glyph.
Yeah, so it's the visibility, the grip has to be visible at each visibility state is basically the issue.
Yep.
Parametric blocks and data link from an Excel sheet.
That's one that I've used data link extensively for all kinds of stuff. Have I used it specifically in a dynamic block? Not yet.
And I've wrote Lisp routines that would take Excel information before and drive the dynamic block, but it would take extra programming to do something like that.
Can visibility parameter have a range instead of number? Example, like from 6 inches to 15 inches. This visibility then 15 to 30 changes to another. I mean, your options for visibility are going to be based on what objects you make visible versus don't make visible. If you're looking for something that says change this distance and then this object becomes invisible, whoa. I mean, you're really getting into an if and then statement, which is not AutoCAD's forte. We might need more information on that one too.
When I delete, did you just answer the delete the visibility state? What happens to the line work?
No, I did not.
So basically, they're asking when I delete visibility state, what happens to the line work in that visibility state? If it was only showing up in that state, it's actually still in the block, and it's going to make the block quite large. You need to delete the line work first, and then the visibility state. Also, you need to make sure that line work's not appearing in another visibility state.
Yes. I think we've got most of them so far. If any other questions trickle in, we'll take those offline and get back with you. If one of your questions, Rick and I said we need more information, definitely let your Hagerman sales rep know that, because that's one thing we want to get in there and get more information, find out exactly what you're using, trying to do, and trying to accomplish. It could be blocks or dynamic blocks is the answer, and there very well could be a different answer that could be more efficient, more powerful for you. But again, any more questions come in, we're going to take those offline and we will get back to you. Thanks everyone for attending, and hope you enjoyed it and have a great day.